Welcome to Let's Code. I'm here with Andy. Hello.
Hello.
And we are working on a lunar lander in Go. Now, if you're binge watching this on YouTube and you've seen every previous episode just now, you won't need the recap. But for those who aren't, previously on Let's Code, we started out just doing a rough prototype of a lunar lander game. Text only so far. Graphics to do. It's easy to say, not so easy to do that one. We'll get to it. And essentially, think of it as a simulation game. You are at the controls of your lunar lander and you're descending towards the moon. So we've got you that far, before the game starts. And now your inputs are basically what's your rocket thrust. We will tell you what your current altitude is above the moon, what your current speed is towards it. The gravity on you is constant, so doing full physical simulation. No corners cut here, and at every stage you enter the rocket thrust that you want, and the idea is to have a nicely soft landing, isn't it? So, for some definition of soft. Any landing you can walk away from. That's probably good. So we did that, and it's I sort of call this main-driven development, in that we're really doing TDD, but in a lot of cases you can't literally start with a test, can you?
In what sense?
Well, if you say I want to write a lunar lander game, okay, what's my test?
Okay.
It's really hard to write that test, isn't it?
Yeah.
You just have to think, well, first of all, what function am I calling? Well, I don't know what functions I need. Why don't you just get off my back with this TDD stuff for a minute, just a minute, and let me do it in main.go, and I'll do something that works, and I can run it. And we did that, and we said, fine. Now we have an idea about the shape of it, don't we?
Yeah. Okay.
We can figure out, if we put this in a lander package, what things might there be. One thing was, we said, well, we need to set up all of the initial conditions of the world.
Okay.
Initialize all of these numbers. So that's one thing. Then we have some kind of loop. It's like, as long as the game's going on, this is what happens. Just repeatedly do this.
Okay.
All games have got some loop like this, haven't they?
But like a refresh state type thing.
Yeah, or like if it's Call of Duty, you can imagine, for player not dead, keep doing whatever. And then we deal with the end of the game, work out whether you won or lost, basically. So we, with the help of successive gophers, we have started writing tests for things and moving it into the package, so it's going well. We have some work to do there, and this is basically, so I happen to know, because I know you, that you're an excellent engineer, and we've worked together on Go projects in the past, but Go is not your primary language at the moment, is it?
No, it's not.
So nonetheless, you're working on some quite complex projects involving testing, and so, as we've discussed, a lot of that work is actually nothing to do with the language. It's more, how the heck do I test stuff, right?
Yes.
or how do I organize things in logical ways? How do I find the right names for things?
That's very true. Yeah. Naming is hard.
Yeah, it's one of the hardest problems, and all of these problems sort of interlock. So a lot of times, we have all the code. Code's all done.
Right.
The only question is now, how are we going to reorganize that? So we're not going to, it's not going to be a searching test of your Go syntax knowledge or anything like that. You'll be relieved
Yeah.
to hear. Yes, on a scale of 1 to nervous, how are you feeling about this?
27.
Yeah. Okay.
Yeah. It's all good. It's all good.
Yeah, we'll see. So really, like I say, where you can be super helpful is in just helping me think about
Hmm.
this and to exercise your taste, which I know is very good, because taste is key to this stuff. Because like, if your program is really badly organized,
Hmm.
how do you know? You
Yeah.
know, you or I might look at it and say, ah, I don't like this. It's all over the place. You know, nothing lines up with anything else. All of the names are wrong. It's more complicated than it needs to be. That's really a matter of taste, isn't it?
That's true. Yep.
It's this sort of aesthetic quality of engineering. It's like if you think about a bridge, for example, you know, a well-designed bridge is kind of a thing of beauty, isn't it?
Yeah.
Or can
Yeah.
be. Um, that's not, one could imagine a beautiful bridge, which nonetheless collapses when you drive over it. So clearly, that's not it's not sufficient, is it? But an ugly bridge, let's say, is sort of we feel instinctively that's somehow likely to be problematic. It's not going to be a very good bridge. You know what I
Yes.
mean?
Yeah. No, I agree.
And I feel a bit the same about programs. Like I can just look at code and without even reading it, sort of from the appearance of it, I can say I feel like this is not very well designed.
That's true. Yeah. I think that one of the telltale signs is if the code style has changed within the block of code itself. So if
Yeah,
one function is coding with tests at the top of it, so if statements or whatnot at the top, but the next function the programmer's decided, well, I'm going to do that in the middle, and then
yeah,
it changes. I find that's a tell. There's no coding standard they've put in place for themselves,
yeah.
um, and no uniformity, I guess.
That's right. And sometimes, I mean, if you develop software in teams, that's hard to avoid, isn't it? You can often see if you look at a code base which has been worked over by dozens of people, it's a bit of a wild west
Mm.
situation. But sometimes that person is just you at different ages, isn't it?
Oh, totally. Yeah.
Looking at something I wrote a year ago, and then I've added some stuff that I've done
Hmm.
now. There's a big discontinuity there.
Yeah, I think things evolve, don't they? I mean, I can honestly say, even in the last few months, my coding has evolved, and to include, different positions of comments, for instance, or
Yeah,
ways I comment, or ways I code loops or if statements and things like that. I know for a fact that it has changed over time.
yeah, and it's like if you think about being a painter or a photographer, let's say, which I know you are, and videographer, part of getting better at that is first of all developing your taste so that you know what images are good, right?
Yep.
And also your technical ability to produce them.
Hmm.
So it's
That's
like knowing what you want, you can refine that, and then you may have excellent taste about what makes a beautiful photo, but you may be unable to actually produce it because
hmm.
you're a bit ham-fisted with a camera. You just get a picture of your thumb.
Yeah.
So this is true in software as well, isn't it? That like you could imagine a well-developed aesthetic sense, but nonetheless the person can't actually code.
Mm.
That wouldn't be helpful. Um, and maybe your coding is wonderful in that each line in itself is a technical masterpiece, like this one.
That's lovely.
But overall, the whole thing makes no sense, and it's just all thrown together. So
Yeah.
these things interlock. So we have some to-dos here. To do fuel
Cool.
makes the game a little more interesting, but we're probably not ready to get to those yet. We're still in this refactoring process of getting it out of main.
Cool. One thing that I have instinctively looked at, and I'm sure you've got the answer right away. With altitude being greater than 0, have you factored in the fact that what happens when it's on the ground? So if it's already starting at 0, how do you get it off the ground? Because it's going to be
Yeah, that's. I suppose that would be like another mission in the game maybe is like, your initial mission is you start at position 100.
Ah, got it.
And so you're already sort of
Flying.
yeah, and then
Right.
obviously with the moon missions they usually start from here, don't they? They're
Yep.
not starting from the moon. But you could imagine once you've got there, okay, let's take an expedition to gather some interesting rocks from over there.
Mhm.
So you can imagine flying around. They didn't have enough fuel to do that on Apollo, but I expect they will in future missions. So yeah, so being able to set up that initial state is something which you could imagine taking different parameters, couldn't you?
Yeah.
Or maybe you could even configure them like difficulty setting or something.
Yep. So, getting into this init game,
Hmm.
is that function, does that define the controls of, or sets the world up and then, okay, so that's setting the world up, and then the controls, how do you start inputting things?
Yeah, great question. So this is clearly a sort of, it's a simulation, not a particularly accurate one, but and again, all games are kind of a simulation of something, aren't they?
Yeah.
Even if it's a completely imaginary world, nonetheless that world has rules, and the simulation is about. You can think of it as a state machine, can't you? Given the state right now, what is the state at the next tick of time? If you're in this case, if you're at 100 meters, you're descending at 100 meters a second.
Mm-hmm.
So, what is your position in 1 second's time? The answer is not a very comfortable one, because
Right.
you just hit the ground.
Yep.
So we can think of it in this sense of like, we know where we are now. We know what the rules are for calculating the next state. The answer is your altitude increases or decreases
Okay.
by the amount of your velocity.
Mm-hmm.
Your velocity itself is also changing because
Yep.
you're being accelerated by the moon's gravity.
That makes sense. Yeah.
And you are also changing your velocity manually by using a rocket engine. So you have some amount of thrust that you're adding to it.
Got it.
It's like if you're cruising along in your car at 100 miles an hour, as I know you like to do, you take your foot off the gas and you're in neutral, it'll just sort of cruise for a while at that speed, won't it? So every second your velocity stays the same, but your position along the road, let's say, is increasing. And then if you put your foot on the gas, that will still be happening, but now your velocity will increase, your acceleration will increase.
Yep.
So you're applying thrust, in essence. So I hope I've got the physics right here. As you know, I've not yet been awarded my physics PhD. I keep writing to them, but they're actually not even answering the letters anymore, which is weird. So it's very much a home study situation, but nonetheless, when we ran this, we got sort of sensible results.
Okay.
We actually played this game, and we tried crashing, see how big of a crater we can make, and we tried doing a soft landing, and that all worked. Unfortunately, now we wrecked everything. By as soon as we started refactoring it and adding tests, we just broke it all. So
Okay. In what way? So what doesn't work?
well, you can already see from all the angry red marks
Yes.
that this is currently not compiling, and the reason is it used to be fine, but then we moved things into the package, for example, and now we're calling them. So we've been taking chunks of code, like we took this code essentially from main, moved it into this package, and then we call it from main. So we completed that one. We need to do the same with the thrust, and I think that answers your question about how do you set the thrust, doesn't it? That we we prompt for it, and you just type it in and press enter.
Yeah.
It's not the most real time adrenaline pumping kind of game, is it? But you've got plenty of time to think about your next move.
And MSS, is that meters per second?
Yes, indeed.
Right.
We'll work in SI units just to annoy Americans.
Good, I'm all for that.
But in principle, this is sort of unit independent, isn't it? As long as you
Yeah.
have a consistent set of units, everything should be fine. So yeah, and one of my mentees who's writing a game, I've been working on it with him, and after we'd spent about 5 or 6 weeks, developing loads of tests, working out what our data structures are, what the core logic is, inputs and outputs and stuff, he said to me, "You know what, John, it would be great to actually play this game." Because we've never actually run it.
Right.
And I thought, yeah, he's right, We've been eating all the vegetables, if you like. We're doing all of this important but dull work. And we never actually interacted with it.
Okay.
So with this, I've sort of made the opposite mistake with this project. That we started by playing the game, which was great, and then we said, okay, now for the vegetables.
Mm-hmm.
And that's, as you know, that really the hard bit, isn't it? I mean, writing the actual game was relatively trivial. Even I managed it in like 10 minutes. The succeeding months have been spent
Writing tests.
yeah, trying to work out how to organise that code, and what. It's not that this is the end state, right? Clearly this is just, we want to extend this prototype to be a bit more interesting, or my games company will be financially unsuccessful. If I want to be up there competing, with the really global companies, I need to do more work. But before we start doing that fun stuff, we really need to get some kind of test coverage, don't we?
And get rid of those squiggly lines.
Yeah, totally. And even if we just wanted to refactor stuff to be a bit nicer or whatever, we kind of want to have the comfort blanket of tests before we start doing that. Otherwise, the only way we have to know whether or not we broke everything is just to keep playing it over and over.
True.
So, so my question to you, and it's a very searching one, is, should we try to get the game running again, just as it is, or should we, continue with the vegetables of adding test coverage? Because I feel like we're maybe halfway through that process, but should we reset to having a runnable game?
Well, it looks like you already have a bunch of tests. What do they do?
We have some tests. So we have a test, new game. I think we changed the name of that.
So I'm guessing these are these are failing, right?
Yeah.
So perhaps the best way to go is to get these tests running first, the ones you've already written.
Yeah. Yeah, that sounds completely believable. It sounds like the sort of thing I'd say. So it must be right.
Learn from the best.
Yeah, so let's see if we can fix what we have then. And so this test, so it's not compiling right now because we have an error at line 46 and I can see the redness.
Yeah.
Read thrust. So this is what we're doing. So to reload the context for your benefit and mine, we were saying this was what we started with. Print out a prompt for the thrust setting, enter something, turn it into a thrust variable, and then we use it. And we said, what if we called that something like read thrust?
Okay, so the input is reading the thrust, right?
Yeah. Now, how the heck do you test a function like that, which prints to the terminal and invites the user to type in? This is just the sort of problem that you're grappling with in your own projects, isn't it? Is how to test things which really do things out in the world. They put data out into the world, or they read data back from it. What can you do?
Indeed.
You've got to supply them with fake worlds, essentially, haven't you?
Yeah. So with this test, so you're saying that you want 10, so you're...
Let me go side by side, split screen vision.
Nice.
Put your 3D glasses on now.
So if I read this correctly with the main.go code,
Yeah.
sorry, where was the defaults part? So your 100s and whatnot.
Oh, that's in init game.
Init game.
So that's here.
Okay, so when you init, you are creating those 4 variables,
That's right.
and once you've done that, you're then creating your loop and asking for an input.
Yeah, we have this concept of the game object. So this is a bit of refactoring that we did. Is originally all of these were just global variables,
Okay.
independent global variables, and we said, we just know aesthetically that that's bad, and we don't like it. But if we had to articulate why, we could say, well, suppose you're putting this game online for people to play in their browser, and you want to be able to have more than one person playing at once.
Yes.
So clearly these aren't globals. They're actually specific to some given instance of the game, and we could have multiple instances.
Got it.
In fact, that's exactly what we want for tests, isn't it?
Yeah.
We want individual different games that we can monkey around with. We're running in parallel, and they won't interfere with each other, which is great. So to look at a working test, we create a new game. Let's call it G. And we're testing its display state method. So these things now become methods on the game to say, game, display yourself. And
so does it? So when you run the game, it is automatically showing you the starting settings.
correct.
And okay, so that's what the lambda display state does. Then the format print does a print out, enter your thrust setting, you scan for that input, but before you scan for the input, yes, you're going to get that printed to the screen.
Yeah, so when we worked on display state, we said what we started with was something like fumped, printf, fumped, printf, all of these.
Yep.
And we said, okay, how do we test this? We don't want it printing to the terminal, not only because it would mess up our test out, but then also we need to be able to look at it to say, what did you in fact write? We need some kind of thing that we can write to, which doesn't appear on the screen, and we can look in it to see what was written. And the answer that we came up with was bytes buffer, which, as you may recall, is it's a writer, so you can write to it with printf and friends. And you can also call it string method to say what's inside you, what's the contents of your buffer, and then we can check it against what we want. So we said, important part of figuring out how to test display state was the ability to pass in a writer for it to write to that we can test. And of course in the real game we send it the writer which writes to the terminal, which is called os.studout. So it's like saying previously this was implicit. We were just writing to standard out regardless.
Yeah.
And then you said, okay, let's make that a parameter, and all the method itself needs to know about its parameter is that it's something you can write to.
Yeah. Okay, that's cool. So you could output it to whatever you want to output it to. You just provide that within the display state parameter.
That's right. And you might remember that Go has this concept of interfaces, where we're saying this is not actually a type of something, it's just a limited amount of information about it. It's saying this could be anything, but whatever it is, it will have a write method you can write to.
Yep.
Or in this case, you can fumped fprintf to it. And that's fine. So lots of different things would satisfy that interface. os.standardout satisfies it.
Got it.
And it has the side effect that it prints to the terminal. A file handle would satisfy that. So if I opened a file for writing,
Yep.
and then I passed that handle to display state, it would print the state to the file. That could be a network connection
Yep.
that I could print over, or if I'm a web server, I could be printing to the web page that goes back to the browser.
Or I guess you could just write your own as well, right? As
Yeah.
long as it implements that particular function and...
Exactly.
Yeah.
That's the beauty of it, isn't it? In 10 years' time, someone could write something which happens to be an I/O writer, and now they can pass it to my function, even though I had no idea that that thing would exist when I wrote this.
So is there a definition of an I/O writer?
Yes. So it's a bit. Let me.
Well, I guess
Close.
I'm just out of curiosity. I'm thinking what are the potential methods you would have to write for it to satisfy being an I/O writer?
Yeah, here they are.
Ah, okay.
So it's quite easy, and in fact, this is the best kind of interface to have. Is one that's really easy to satisfy. Because you can imagine if you had 50 methods, and maybe you're only going to use one on your particular thing, nonetheless, you'd have to stub out all the others.
Yeah.
Just to make the compiler happy, wouldn't you? Which would be annoying. So small interfaces are great, and the two canonical ones in the standard library are reader and writer, and you can guess what reader is.
Yeah, sure. So sorry. So going back to your code, your display state is implementing two interfaces, a reader and a writer.
Display state actually only writes.
Okay.
So it just prints its output to whatever writer you give it, and that's it. It doesn't need anything else, so it only takes a writer. But that starts to give us a clue about what we might need to do with the thrust, isn't it?
Okay. Okay. Yes.
Because if we moved this into a method called read thrust or something like that.
Well, sorry. The bit with the string method where you were reading it back out of the buffer.
Yeah.
What was that implementing? So your bytes.buffer.
Yeah.
Okay. Okay.
That's right. The point is that an interface specifies a set of methods, but it's not exhaustive. You can have other methods. The interface just doesn't say anything about them. In this case, the bytes buffer has a write method, but it also has a string method. And other different types of things would have different methods, but that's okay. So that's really nice.
I see. Okay.
Don't know what methods OS standard out has. I don't even know what type it is, but we can find out. It's a pointer to file.
Aha. Cool.
So this is Unix. I know this. Everything is a file.
Yeah,
So that's good.
I'm sure that has a lot of extra bits and pieces on it you could use.
Yeah, but I don't need to, which is nice. So my code doesn't need to know anything about whether it's a file or not. So our thoughts are starting to come into focus, aren't they? In that if we take this block of code and we're making it a method, and we want to test it, we're printing something. So we're going to have to give it a fake writer to write to, or it's a real writer, but it doesn't appear on the terminal.
Yeah.
We're also going to need to give it something to read from, aren't we?
Yep.
Is this fumpt.scanln is the opposite of print, if you like. It waits for you to type something, and then it tries to turn it into whatever variable you gave it. So, in our read thrust test, we know we'll need to construct these fakes. So we know how to do the output buffer. So we've just called that output, because now there's two buffers. We can use a buffer for the input as well. All we do is we put something into it beforehand.
Right.
That's neat, isn't it? We've sort of pre-stuffed this input in there. We'll pass it to read thrust, and it will hopefully suck that out.
Yeah.
And turn it into... And it'll have some effect on the game. Otherwise there's no point to it. So it doesn't actually return anything. But if we call this and it works correctly, then if we look at g.thrust, it should have changed.
Got it. So, yes.
To what we said. So that sort of makes sense, doesn't it?
Yeah, that's cool.
And we've said, well, look, this test isn't actually testing what you printed, but you know what? I don't even care about that. I just want to take a moment to tell you about a series of ebooks I'm writing for Go beginners called For the Love of Go. In Book 1, Fundamentals, I show you how to write tests in Go and how to build programs test first. In Book 2, Data, I tell you all about variables and values in Go, and data types like slices and structs. If you're new to programming or just new to Go, I'll show you everything you need to know to start building fun and useful projects. Go to bitfieldconsulting.com/books and enter Code Club at the checkout to get 25% off now.
So right now, the problem is that it can't see the function. So it can't see display state in the read thrust.
Yeah, we didn't write it yet, of course. So we're proceeding strict TDD style. Just forget about the prototype. That never happened. So we're good TDDers. So we've written our test, and we've just said, we're in parallel, create a new game. Because we're not testing new game in this test, we don't care about the error it returns. We have another test for that. We want the thrust to be 10 after this all worked.
Yep.
Here's our fake user typing fake characters. Here's our don't care output to throw away stuff to. Here's the method call. Now we look at gthrust. Is it correct? If not, fail. So we're sort of there with the test, aren't we? It feels like.
Yeah.
We're nearly ready to. If we run this, we should get the same compile error. Yes, we do. Game has no field or method read thrust. Fine. I believe that. What can we do? Well, we can write one. Let's do that. So we know it's a method on game. So that bit's done for us. We know its name because we made that tough design decision last week, I think.
Okay. Yep.
And we said it's going to take a fake writer, just like display state.
Yep.
So that bit we can copy. It's also going to take a reader. So I called these things input and output, meaning this is your input.
Yes.
Here's where your output goes, Mr. Read Thrust. So let's do the same.
So you need the reader beforehand?
With these. So this is output, isn't it?
Yeah.
And we've said input is first, doesn't matter.
This is your... okay.
So that looks alright, doesn't it?
Yeah, I can read it. So.
Yeah, great.
Yeah.
That's a really good start.
Yeah.
Okay. When we first implemented display state, we said, we're passing in a bytes buffer. Fine. When we wrote this, we said input bytes.buffer. And then we realized that was wrong when we went back to main.go and we said, we don't have a buffer here. It's actually standard out. That's not only is it standard out, but it's not even a bytes buffer. It's something else. So it didn't compile. We realized what we should have said is IO writer, and because that's an interface, it allows us to pass either a bytes buffer if we're the test, or a pointer to file if we're the real game.
Right.
Which is nice. So same thing here. The input in the real game will be os.standardin and output standard out. That's fine. In the test, they're both bytes buffers, as we know, because we just wrote that. So and we don't return anything right now. So what's the minimum we could do here to make it compile and just see if our test is now failing instead of failing to compile? We feel like we don't want to write the whole thing. We just want to make it compile. So do we actually need to do anything?
So you said that you don't need to return anything, but I thought the point was...
there's nothing here. So if we returned an int, let's say, then now this wouldn't compile because it's a missing return. So we'd have to do something like return 0 just to placate it. But in fact, we haven't got that. Therefore, this function is fine. Don't even need a line break. You can just do that.
So will it return just a null?
It doesn't return anything. That's the point. So when we call it, there's not even an assignment here with anything on the left of it. So.
Okay. So it's just a function to run.
Yeah.
With no return. Right. Okay. Gotcha.
That's right. The only reason for having it is that it has a side effect on G.
Yeah.
It alters G.thrust. And we could have had it return the thrust, but then all we do is just assign that to G thrust. So, hey, you're the G. Why am I doing your paperwork? You do it.
Yeah.
So, I feel like we should be almost ready to run.
Sorry, I'm probably being a bit silly here, but I would have thought that those would have been from a naming convention. They would have been the other way round. So G.thrust is where you put your input in. You're gonna do your thrusting.
Mm-hmm.
You're gonna thrust with your +10 or whatever it is, and then when you want to read back, you want to find out what you've got, you would read the thrust as it is now.
Ah, yes, I see what you mean, yeah. So you think like G thrust could be interpreted as something like set thrust, whereas read thrust is tell me what thrust I currently have. We started out by calling this something like prompt for thrust, but then we said, you know what, we don't always want it to be type in your answer. We would actually quite like to have real-time play. Maybe we just sample the keyboard to say, are they pressing the up key? In which case increase thrust. More like
input thrust.
Yeah. So right now this is a mainframe game from the 60s. We would like to bring it forward to a home computer game of the 80s, wouldn't we? Like maybe even draw ASCII art graphics of a rocket and stuff. But let's keep our enthusiasm in check for the moment. So, yeah, the thing is we'll probably bike shed all of these names to something different later. That's fine.
Okay.
The structure will be more or less the same. And one of the reasons we would like to have these tests is so we can do all of that bike shedding and refactoring.
Okay.
Because you know how I love to do that.
Mm-hmm. Okay, yeah, I've got my head around it now. So yeah, okay. Read thrust is you're reading the thrust input, and G.thrust is you're reading the thrust value.
That's right.
Yeah.
So it so happens that new buffer string, which is a convenience method, you can imagine you could just create an empty bytes buffer, write to it by calling its write method, so that it now has some bytes in. Mm-hmm. This just saves you doing that.
Yep.
But it returns a pointer to bytes buffer, which is almost always what you want. For the interesting reason that a bytes buffer value is not an IO writer. A pointer to bytes buffer is an IO writer. Why is that? Because writing to the buffer modifies it, doesn't it?
Say that again.
So suppose I passed my bytes buffer to my function and the function wrote something to it.
Mm-hmm.
Since Go is passed by value, what you're actually receiving in the function is a sort of a local copy of that buffer.
Yeah.
And I can write to that all I like, but then it just gets thrown away when the function returns, and the original one has had no effect. If I want the function to have an effect on it, I do here, I must pass it a pointer, otherwise it has no way to access my original variable. I'm over here, I
Yeah.
want to access this variable over here. Now I normally can't do that unless you pass me a special handle to it, which we call a pointer, because it's like you're pointing to it saying, hey, it's over there.
Right.
Modify that one.
Okay. Okay.
So this is a bit inside baseball, but the point is that IO writer is a thing which you can write to, and you can't write to one of these or it would be a waste of time. You need the pointer, so it's the pointer that is the IO writer. That's clear, isn't it?
Yep, I get that.
Interestingly, the same is true for reader. That sounds a bit weird, doesn't it? Like, why am I modifying it by reading it? But you really are.
Yeah, I guess.
Because it knows how much of it you've read, if you like. You might be halfway through reading whatever it is, so next time you read it, you want to be reading from there. So it has some hidden internal state.
Right.
Which reading from it implicitly modifies. So, yet again, you need a pointer, so that's fine. We need 2 pointers, and we have them. So that one returns the pointer. We created the pointer ourselves with this one. That's great. So, we feel like this test should run and fail, don't we?
Yep.
Let's find out. Bosh, we're there.
Okay, cool.
So wanted thrust to be 10. It was 0 because that's the starting value.
Yeah.
Over here. So we're ready to write this, aren't we?
Yeah.
In fact, we kind of already wrote it partly. We have this code. So let's snaffle that. Replace that with a placeholder. Okay, this isn't going to work as is, but we can tweak it, can't we?
Right. So we don't have thrust. We want IO reader, which is input.
So we're going to be printing a string. That's all right. I feel that's well within our capabilities. We're going to be scanning input from some IO reader. We can probably do that too, can't we? So fumped print doesn't take a writer to print to because it implicitly prints to standard out. Fumped fprint, or fprintf in this case, takes a writer, so that's the difference, isn't it? That's what we need. So we need fprint, just fprint here is fine. We need to send it the thing to write to, thing to print to. That's output. So we're halfway there, aren't we?
I see, yes.
What do we need to do here? It's sort of the inverse situation, isn't it?
Yeah, so is there a... So the difference between print and fprint, what are those differences?
Print... So you can think of it like you don't need print. You know, you can get by with just fprint, and when you want to print to standard out, you give it standard out.
Okay, so
That's the writer. But there's a convenience method to save you having to type that every time, because it's quite common to want to print stuff out. So just print.
Okay.
It's sort of like shorthand for fprintf to standard out.
Got it. Okay.
So similarly, scanln.
Yeah, this is where I was going. So
Yep.
is that scan ln by default going standard in? Or is
Yes,
there like an F scan ln?
Exactly so, yeah.
Right.
So this is like, so I feel like, I hope this is true, I feel like there should be an fscan ln, same pattern, right? Stick an F in front. Not sure what the F stands for, but you can make up anything you like. I've got some ideas.
Yeah. All right, so input as a pointer.
That's right, we received it as a pointer, so we can pass it on. Undeclared name thrust. Okay, but in fact, we know it's g.thrust, and we're a method on g, so we have g, if you like.
Yeah.
That's sort of the one thing we do have. So that would be just g.thrust. Will this work? The compiler looks happy.
So the G at the top, or game, so that's if you scroll up a little,
Yep.
so that's that.
That's this struct, that's
Yeah.
right.
Okay.
There's not much in it at the moment, just 4 float 64s.
Okay.
So, this is very encouraging. So, we're saying for a given G, and if you give me a reader and a writer, I will output the prompt message. We don't really care what that is because we're not testing it. We'll read something from the input, try to turn it into thrust. That will presumably just panic or something if it's not. If you type in hello, that's not difficult to turn that into a meaningful float 64 value, isn't it? So
sorry, before
we'll see what
we carry
happens.
on, the one part that I'm slightly confused about is the input. Now, you said that and the input has to be a pointer as well as the output being a pointer, because if you read the input of a buffer, then you're altering it. So why does the input keyword here not have the ampersand in front of it to say that it's a pointer?
Yeah, it's a good question. I think I probably said it a bit wrong in that, an IO reader is just simply anything that has a read method.
Yeah.
Nothing.
And you're calling that input.
Yeah, no information about pointers or anything like that. It's just literally whatever kind of value this is, I expect to be able to call a read method on it. Now, it so happens that a pointer to bytes buffer does have a read method. If we dive into this, we'll find its read method somewhere. It's got a ton of methods, none of which are mentioned in that interface. Let's have a look. Here it is. Here's read, and you can see that its argument is a pointer to buffer. Its receiver, I should say correctly, is a pointer to buffer. Now what that means is, if you have a buffer value and you try to call read on it, that just simply won't compile.
Okay.
The compiler would say, what you're asking me for is a method that has a receiver which is a buffer. But there is no such method. I just can't find it anywhere in the source. I could find a method on a pointer to buffer. Is that what you wanted?
Got it.
Yes, it is. So that's why if something requires an IO reader, you can give it anything which has a read method, and we now know that only a pointer to bytes buffer has a read method.
Okay.
A value doesn't. os.standardout, as we saw, is a pointer to file, so it's already a reader. That's okay.
Okay.
You could imagine, you could write literally any type of your own, couldn't you, which has a read method, and it would be perfectly acceptable input here.
Okay. Yeah.
Whether a pointer or not. So I probably sort of gave you a bit of a red herring there, sorry. But so this doesn't need to know whether or not its parameters are pointers or whatever. It doesn't care. All it cares is their IO readers. In fact, it doesn't even care about that because the compiler will worry about that.
Okay. Okay.
So
on the right hand side, so within your test, so the test read thrust part, yeah, here. So you've got input as a bytes new buffer string.
Yeah, which returns a pointer to buffer.
Which returns a pointer. So, and you're just calling input as a label to that buffer.
Yeah.
To that pointer, sorry.
Yep, I named my pointer input, and I'm passing it to read thrust. So that satisfies IO reader.
Right. Okay, I got you.
I had a buffer that I called output.
But that does not. But that's not the pointer to the buffer. That's
Correct.
Just the buffer. Right. Okay, that's the difference.
And I know IO writer. I know a bytes buffer is not an IO writer, but a pointer to such a buffer would be. So I need to use the ampersand to create a pointer here.
Right.
I could equally have created it here.
So yeah, okay, I got you. So the one is returning just the buffer, and one is returning the pointer to the buffer. So input is returning the pointer, or bytes.new buffer string is returning.
Exactly, because the people who wrote this method were clever, weren't they? Because they said it's no good returning a bytes buffer. That's no use to anyone. It's not a reader or a writer. What people probably want this for is to be an IO reader or writer. So we'll give them the pointer, save them a bit of paperwork.
Got it. Okay.
This is a nice thing to do in your own libraries, isn't it? Is if your thing, whatever it is, just has a bunch of pointer methods, then people are going to need to call those methods on a pointer to your type. So in your constructor, you may as well return a pointer. Save them a little bit of work.
Got it. All right, that's cool. So
we should be running and passing now, I feel, shouldn't we? Should we have a try?
Are we actually inputting? Wait. So you're inputting. You want 10. Oh, and you're inputting 10 from the new buffer string. Yeah,
that's right. This is my fake user typing here. They typed 10 and they pressed enter.
Yeah. Okay. Yeah, I think we would pass.
Let's see. Nope.
Okay, so you got 0. Gee.
Let me just try running go test here just to make sure.
Has it got to be a decimal point? Has it got to be enter 10.0?
Could be. Let's try that.
No.
Nope. Thing is, if you have a float 64 value of 10, that's the same as 10.0, isn't it? So clearly something's going wrong. So are we printing to our output? Well, it doesn't matter. That has no effect. Are we correctly scanning from our input? fscanln takes a reader. Well, we have one. It takes a bunch of things to scan into, and we sent it one. And it actually returns how many and whether there was an error, but we don't care about those. Maybe we do, though. Maybe it wasn't safe to ignore those. So should we try just printing them out?
Yep.
And say, it's always a good technique, isn't it? To be completely frank with you, I don't even know how to operate a debugger. I just print stuff.
Yeah. Okay.
That's my debugger. So let's find out. Oh, n was 1 and error was 0. That sounds promising. So we read one thing and there was no error. So where's it gone?
So
because g.thrust is 0 here. So should we try spying on that as well? Should we print out what thrust is beforehand? The before and after pictures at Weight Watchers. Here's the thrust before. Here's the thrust after. And we'd like them to be different, wouldn't we? But we suspect that they won't be. Let's find out. Thrust before 0, thrust after 10. Oh, that's really confusing.
Is it reading just the first byte of the input? Like, well, it seems like it's...
Thing is, you can see here it's worked, hasn't it? It's correctly read the input, set the thrust to 10, and we're all good. The only problem is over here, somehow, that seems to have not changed. However, the way I phrased that might just jog our brains into thinking, that sounds a little bit like the discussion we were just having about pointers, doesn't it? We said, if you don't pass a pointer, then you can modify that all you want, but it has no effect on the original thing, only your copy of the thing. If you want it to be modified, you've got to send a pointer.
So the got here has got to be a pointer.
Or what are we saying? So we're calling g.readThrust. It's really, we understand that methods are just a kind of syntactic sugar for saying, I'm passing you the G, right?
Yeah.
This is reasonable, isn't it? It's just like, it's boring to write this if all of your functions have to take G in order for them to do anything. We just say, fine, let's just put it at the front, and then it's still a parameter here of a kind, but it's over here on the left by itself. But we understand this is effectively the same as having it here.
Yep.
But if we put it this way, all of a sudden this looks quite suggestive, doesn't it? Because we're saying, oh, you passed in a G, and then you did some changes on it.
But we're not passing that G back.
Or exactly, but we're modifying it. But we're modifying our local copy.
Yeah.
Is that going to have an effect on this G? No, it's not. I already explained at probably too much length why that won't work. So I've sort of been hoist on my own petard, haven't I?
So,
whatever that is. Sounds painful.
The test, does that have to, the got is going to say, well, I've got nothing because this is my own local copy that you've not changed. So the got has to be pointing to the game that you've just changed.
You're very much on the right lines. So it's definitely that we know the problem now is that we have a value, not a pointer, isn't it?
Yeah.
That's definitely what's the problem. But is the problem over here or is it over here? I think it's over here.
Okay. So with the scan line, you've got the pointer to G thrust.
Yeah. Let's just look at bytes.buffer again to remind us what that pointer method looks like. This is a method on a pointer to bytes buffer, isn't it?
Yeah.
So what's different about this signature from the one that we have over here?
Oh, okay. So
it's this, isn't it?
Yeah. So you're a buffer pointer.
That's right. This declares a read method on a pointer to buffer. This declares a read thrust method on a not a pointer to game, just a game. We need a star here, don't we?
Okay, so why are you using a star as a pointer up there but an ampersand within the code to reference the pointer?
They're essentially the inverse operations of each other. So here we have a value and we want to turn it into a pointer, so we use ampersand. Think of that as create pointer. Over here we have a pointer and we want to turn it into some value, we use the star operator.
I gotcha.
That's like dereference a pointer if you want the $10 word.
Yeah. Cool. Okay.
So if you ampersand something, you need to star it at the other end to get back the original thing.
So if G is now not a pointer because you've just dereferenced it, you've gone. It was a pointer, but now I'm going to make it the object.
Yeah, well, I've not actually done that just by declaring it in my function signature. All I've said is you can kind of read this as pointer to game. You could just pronounce that as this is the way that we spell the type called pointer to game. Okay. We use the same operator that we would if we had a pointer to game and we wanted to get the game, but
right. Okay.
We're just saying it, if you like, not doing it. So G is a pointer to game. Thank you, VS Code. It's reminding me. And now this feels like it should work, doesn't it? Because it actually was working in that it was doing what it was supposed to do, and we saw that from the printout. It just wasn't persisting because we were writing to our local copy, which we then threw away as soon as we returned.
Yep. And
the original G, the OG, if you like, was not modified, which was why we're failing.
Yep.
So
So now you've got it as a pointer. It is, or should be, writing to G, and so your test will be able to hopefully read it.
Yeah, I'm kind of putting my head out the train window here, aren't I? And if everything I've said is right, then this test should pass, and if it doesn't pass, that kind of makes me an idiot. So
Oh,
let's
no.
see.
Well, let's
It's
pull the
a
trigger.
it's a tense moment in the studio. Okay, good. That's,
Good.
I
Okay.
wasn't sure myself there. Um, so that's encouraging. So we can take out our prints.
Mm-hmm.
Um, in fact, we should have seen them, shouldn't we? Why didn't we see the prints? Oh, because reasons.
Is it not?
For some reason, VS Code's run test thing doesn't always seem to be up to date. So that's fine. So now we can take out
Mm-hmm.
what we might call our debug instrumentation. Sounds better that way, doesn't it? Sounds better than print statements.
Print stuff, yeah.
We don't need to receive these anymore because we know they're all right.
Do you have debuggers? I'm guessing you have debuggers for Go.
Yeah, you absolutely do. Yeah, the canonical one is called Delve.
Okay.
And it works really well. You can do all the usual stuff.
Yeah, cool.
Set breakpoints, single step, step over, step into, inspect variables. I think even set variables. So that's very nice, and I'm really glad that it's there, but I'm also really pleased that I so rarely have to use it.
Okay.
That's either because Go is a great language, or I'm just a programming genius. Leave that to the YouTube comments section to decide. So that's really good, isn't it? So we've done that. We won, and we can now fill in this bit. So our game object here is called lander.
Right. Yep.
That's just, we haven't done that bit yet. So we should do what the test does, which is we should do.
Yeah.
Used to be called init game when the variables were global, because it initialized them, and then when we said, no, we want a game object, now init game actually has to return it, so it's logical to call it new game. So we fixed that. That can error, interestingly.
Okay, why is that?
Well, this is a decision made by I can't remember who now. This is a nice thing. So many people have worked on this. It's difficult to pin the blame for any specific mistake on anyone, and that's the joy of it, isn't it?
So what is it actually erroring?
So we said, so anytime we write a function, we say, what does it need to take? What does it need to return? And we're usually doing this from the point of view of the test, aren't we? So that helps us answer these questions, and we usually want to ask, does it need to return error?
Right.
Because if so, we have to decide now, because we have to fill that bit in. And my way of answering that question is to say, well, can it error?
Okay.
Like if literally nothing can go wrong with whatever you're doing, then it seems a waste of time returning error, because it'll always be nil.
I see.
If there's any way at all for this to be anything other than nil, we need to return error.
Okay.
Clearly it can't from this code. But what we said was, so we said, right, executive design decision called upon. Let's have a spot meeting and figure it out. So we said, can this error right now? No, of course not. We're just creating a struct literal. That can't fail. It could fail to compile, but that's a different issue, isn't it? It's not a runtime issue. But could there be runtime issues? Yes, you could imagine them, couldn't you?
Right, so later on down the line.
Yeah, in your web-based multiplayer lander game, let's say, maybe you've just run out of memory or something, or some other problem, or more to the point, you could imagine if new game takes parameters such as difficulty setting, amount of fuel, starting altitude, starting planet,
Mm-hmm.
even number of players. Some of those inputs could be invalid, or we could conceive of that. So not literally every possible value might be acceptable, so we would like to be able to validate them, and therefore we're saying at some point in the future this could potentially error. So we'd like to build it in now so that, I'm sure there are hundreds of people out there looking at the GitHub repo building games based on this engine, aren't they? So they'd be annoyed with us if we changed the signature of this function because all of a sudden their programs break.
Yeah, sure.
Even though they're not using that value, it doesn't matter. So we said, let's, normally we wouldn't do this, would we? We would say, oh, I don't need it now, then I won't do it now. And that's nearly always the right decision. But on this one occasion, we kind of said, yeah, we can definitely predict that if it goes where we want to go, it certainly will be returning error in the future, so we'll return it now. So let's pretend that it can error, so let's just check that. So let's just say this. We can think of a nicer user interface, but that'll do for now, won't it?
Yeah.
So now we have our G. So now that's G.displayState, no problem there. Let's get the thrust. This takes something, doesn't it?
Mm-hmm.
It takes the input to read from, which in this case is standard in. And just like display state, it takes standard out. That's alright, isn't it?
That's cool, yeah.
And if you just looked at this code in isolation, you might say, why in heaven's name are you passing in standard out to all these things? Of course it's standard out, what else would it be? And the answer is, well, in my test, it would be a bytes buffer, for example.
Yes.
So if we were smart, we'd look at this and say, wow, looks like this programmer went to the TDD school. They injected their dependencies, didn't they?
Yeah.
Which is nice. That sounds painful too. I don't know why anyone would want to do that. But there it is. And you can, and if we were to continue that pattern, we can sort of see what we'd do with this, can't we?
So these are going to be part of G as well, right?
Yeah, I mean, we could talk to them directly by making this G altitude. Let's do that actually, because it'll be nice.
And then I get create functions for each one to alter.
Maybe. And so
I'll be honest. What the one bit that I've in my head I was getting confused about was within your Lambda Go, or your functions within your Lambda, were not nested within the. So if you scroll up, I was like, well, you're describing your object game and for floats, and literally that is it. There's no functions, there's no nothing. But I'm assuming, in Go, that's not how you do it. So
that's just a syntax issue.
Okay.
Yeah, so if I understand you right, you're saying that you could imagine a syntax where it was like method goes here.
Yeah.
That would be fine.
Okay.
Just isn't that way. So it's sort of conventional to put the struct first. That's what everything else is about. I do see people who put the struct at the end. It just seems kind of weird. Do you start reading a novel from the last page and work backwards? Maybe.
I think it was more to do with scope. So from sort of my world, the function is, if it's within the structure, then, or the class as it were, you can affect things within the class. But if the function is outside of the structure, then that's like in the global domain.
That totally makes sense. And one thing you can say about this way of doing it is, if all of my methods had to be within these curly braces, that's a nice visual layout. But suppose I had some other source file and I wanted to add a method to game that's in that file. Well, how am I going to do that? I can hardly get it in between these curly braces, can I?
Okay.
So having it outside at package level, if you want to call it that, is a little more flexible.
Got it. Yep.
So that's great. So actually, we're almost sort of there to fixing it, aren't we? And to just complete that thought is what I was going to say next. Is you could sort of imagine maybe we shouldn't even be seeing this level of detail here, and maybe maybe we should do something like g dot update world. Update world, something like that.
Yeah.
I was reading a really interesting article about Quake recently. It was on Hacker News, and one of the Quake developers was writing about how they did it, how they updated Doom to real 3D and stuff like this. And they were talking about the architecture of these games, and as we said earlier, they're all basically the same. You have some sort of world which has state, and the way the game proceeds is get the player's input, or get all the players' input, update the world based on everything that's happened. Physics, things are moving, bullets are moving, rockets are moving, players are moving, and push that updated world to all the players. So inside Quake there'll be some method called update world. Except it'll be written in C, so
nice.
I'm glad I don't have to write it. And interestingly, he was talking about how they implemented the network play, and this is a fun problem, isn't it? Because you imagine if we turned this into a networked multiplayer game, maybe I have a lander and you have an attack lander that's trying to shoot me. We're sharing the same world, in a sense. Otherwise, it'd be a really boring game. But you have your computer and I have mine, and we're playing separately. So your world needs to be in sync with mine, if you like, doesn't it? So that's kind of a sync problem, which is hard in principle. And one way that you could imagine doing it is saying, actually, this world is quite big. I don't want to have to. I'm obviously not going to push every triangle and vertex and mesh and texture to you every frame 60 times a second. That would need good broadband. So we figure we both have the basic world, all the textures and meshes, and then we just move around it, players and monsters, if you like, so entities within that game. So one way we could do is to say, I'll just send you updates. I'll just, as the game server, I will just send you the diff from the state that I know you have. I can say, Andy, John has moved 10 meters to the left. Please update your world accordingly.
Okay.
Right? That makes sense to us, doesn't it?
Yeah.
As a way of doing it. And he said, the problem with that is it didn't work.
Alright.
What happened was, as you can imagine, worlds got out of sync. Networks are unreliable, packets get dropped, and if you miss an update, from now on forever your world is out of date. You will never get that update again, and you'll be permanently out of sync. You'll be shooting me and why won't you die? It's because I'm not really there.
Is that because just in that example I could see that if you were saying the update says you've moved 5 to the left, but I could see if you missed that packet and then the next message was, okay, move another 10 to the left, you've only moved 10.
Yeah.
If you haven't got the first 5 instead of the 15 that it's supposed to be. However, if it was something like, okay, this character has moved to this particular location and you don't get that information, okay, you don't get that one particular update, but they're going to kind of skip to the right place.
Yeah.
If you get the next message saying, okay, the player is now in this location, it doesn't matter if you've kind of missed one, per se.
Yeah, that's right. And basically, this whole sort of idea is full of potentially thorny problems, isn't it? Anytime you can lose sync, basically something weird is going to happen.
Yeah.
Something weird and undesirable. And players will get cross. So they said, actually, we just had to send the whole world to everybody every time.
Wow.
And that worked perfectly.
Okay. So is that what they still do?
Yeah, and he said, we don't literally send the whole world every frame. That's not necessary. What we do is just send it every so often and let the local game interpolate between the two.
Right.
Like in-betweening an animation, right?
Yeah.
I said you at time t, John is here. At time t plus x, John is over here. Now you just fill in. He must have moved smoothly from one place to the other, unless you've got a teleport. So
Really?
you fill in the missing frames, and you can do that locally very cheaply.
Wow. So you do get quite a lot of bandwidth going.
Yeah, this is why network administrators back in the day used to get really cross with people playing Doom and Quake, isn't it? It's like, especially at university, they're like, this you're using up a lot of valuable resource here. But we
Can't
ignored
imagine
them.
what, like Fortnite and those types of games, what they do to the broadband, and if they must be doing compression and whatnot. But
Yeah, but fundamentally, I'm pretty sure they'll work a similar way to that. The network is now a lot faster than it was in Doom Quake days, but also the game is much more complex and detailed. So that makes sense. So that was very interesting, and I guess I'm sort of hinting at maybe next steps. Here is like we're almost through packagizing this game, if that's a word, aren't we?
Mm-hmm.
We did an important bit here. That was very good. The next thing might be update world, and then some sort of, print end of game message.
Yep.
Or whatever, and then maybe even this logic goes away from main. Because why do we need it over here, right? It's all about the G. The G's over here.
Right.
So maybe all of this goes away, and it's just replaced by something like, or
Start
not
game.
all of it, but I couldn't undo for a second there. I was like, oh my god, I deleted it all. It's like, okay, we've got the G, we don't actually need to do all of this logic, because that is actually part of the game itself, isn't it?
Right.
The presence of that loop is a key part of the game. So we might replace it all by just G dot run game, method name TBD, but something like that.
Nice.
And then maybe it returns something, that tells you, and you could ask, would you like to play again? Y/N. But that's certainly a nice direction, isn't it?
Yeah. The update world would receive the input.
It would do these, basically.
Oh, and because you've already got the G over there.
Yeah, exactly. So we're saying having,
Right.
in this frame, if you like, we've drawn our world, we've got the player input, we need to do the science bit, if you like.
Yep.
Update all of these parameters based on what's happening. And that's kind of it, isn't it? Like those three things are all of it. That's the game loop right there. And I haven't read the Quake sources, but I'm sure there's something that looks a bit like that.
Indeed.
But written by John Carmack instead of me. So that's great. So I mustn't trespass too far on your valuable time, but you've been a huge help today, so thank you for that.
No worries. Thank you. Thanks for having me look at your cool game.
It's been a really fun session, so I will commit this stuff and push it up to GitHub. I'll put the repo link in the description, and I will co-author you on this commit, just like I have all the others.
Oh, cool.
So that's great, and next time I will be back with another willing victim to do the next stage. So I hope to see you all then. Bye for now.